Good morning. This is going to be a lesson about writing numbers in scientific notation and interpreting numbers that are written in scientific notation, and then doing a little bit of calculating with scientific notation. You guys know that in science, we often use really small, really large numbers. For example, this first number is something we might learn to calculate this year in chemistry. It's the number of water molecules that are in an 8-ounce glass of water. This is a huge number. If we add our commas in here, we can see this number is so big that if you started to count right now and you counted one molecule for every second for the rest of your life, you couldn't count all of those molecules. This is the millions right here, the billions, the trillions. Oh my goodness. Look how huge this number is. And certainly when we have a number that's that large, we actually cannot, when a number is that large, fit it on the screen of our calculator. So we need a way to express this number that makes it a little bit easier to work with. There are some rules for writing numbers in scientific notation. I'm going to review them now because I think you've had them before in other science and math classes. But remember that you put a decimal in the number somewhere to make a number that is 1 or larger but less than 10. For example, 7.9 is bigger than 1, less than 10. So that's good. Now the question is, how many times will we have to multiply 7.9 by 10 to get this number? So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. We would have to multiply by 10 24 times to get that number. These two numbers represent equivalent quantities, equal numbers of molecules. It's just that the first one was written in standard form, and this one is written in what we call scientific notation. We can also use scientific notation for really small numbers. Like here is the mass of an electron in grams. So we'd want to put our decimal right there, 9.1. But as you can see, we need to take 9.1 and we need to divide by 10 a number of times to get this number. We'd have to divide by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8 times. So we would have to divide by 10 28 times. Now, if you've ever had a number in algebra like this, like let's say you had 9.1 over x squared. If you bring that x squared to the top, you just make it x to the minus 2. That's what we do here. This is the same as 9.1 times 10 to the negative 28. The negative 28 is just telling us that we divide by 10 that many times. This is proper scientific notation, and it is equal to that original number. Here's another one, a little easier to count. We'd have 4.75. 1, 2, 3, 4, 5, 6, 7. We would have to divide by 10 7 times, right, to get 4.75 to equal this. Since we have to divide by 10 7 times, do I want a positive or a negative exponent? Think about that. That's right. I'm going to want a negative exponent. In today's lesson, we want to be able to accomplish both of these things: interconvert numbers between standard and scientific notation, and then calculate using scientific notation. So if you don't have a calculator handy at this point, you want to put this presentation on pause and go grab a calculator. Whenever we have screencasts, you're always, always welcome to put the presentation on pause and fill in notes or take notes on the presentation. In fact, you're not just welcome to do that, it is highly recommended that you do that. Okay, so what I want you to do, okay, put this on pause and take about a minute and try to jot these down in your notebook and put them into scientific notation based on the 3 examples that we just completed. Now, hopefully you did put it on pause and complete that activity. Okay. Let's go over the answers you should have, and you can self-check. Here I'm going to put the decimal between the 9 and the 5 because it has to be less than 10, has to be equal to 1 or greater. I would need to take 9.5 and multiply 1, 2, 3, 4, 5, 6, 7, 8. So multiply by 10 8 times. On the next one, 2.93, and I'd have to multiply by 10 5 times. On the next one, 8.7. This time I would have to sorry about that, divide by 10 3 times. So we know how we indicate that. We use a -3. And on the last one, 7.7, and I'd have to go 1, 2, 3, 4, 5, 6. So 10 to the -6. These are written in proper scientific notation. To be proper scientific notation, those first numbers have to be 1 or greater and less than 10. Now, one thing you're going to see occasionally is an engineering notation being used. When an engineering notation is used, this part right here is replaced by a capital E. Like this might be written 9.5 capital E, and then the 8 is just written large. It's not written as an exponent. As you're going to be typing a lot of things this year, this may be easier to type than times 10 and highlight and superscript the 8 to use this engineering notation. If you ever plan to take physics, they're going to use this notation. And your calculator may very well use that notation. So let's write all of these in an engineering notation. You might be thinking, what do you do when it's negative? You just put that negative right there. This means 8.7 times 10 to the -3. Just put the E in the place of the times 10. Okay, on the next screen, okay, what you want to do is take these numbers that are in scientific notation and put them back in standard form. So say, for example, it says times 10 to the 4th. That doesn't mean add 4 zeros. That means multiply by 10 4 times. So the first time makes it 25. And then the next 3 times you have to add zeros. In this one, the -3 means we are dividing by 10 3 times. The first time makes it 0.365. The next 2, we need to add zeros to fill the place. Now, I always put a 0 at the beginning in front of the decimal because that is proper. Okay? Not going to mark you wrong, but it makes it a lot easier to see when you're writing or typing. Give the next 2 a try, remembering that the large E is the same as times 10. So pause the presentation and write these 2 in your notebook to try them. Now, hopefully you paused the presentation and you tried those. This one, how'd I lose my pen here? Hold on. This one, we need 6 zeros. 1, 2, 3, 4, 5, 6. And sometimes it does that. Sorry, that's just a little random line. And this one, we're multiplying by 12 or by 10 12 times. Here's 1, 2, 3 times 2, 2, 9, 5. So I need to add 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can put the commas in if you want. Sometimes that helps. That's 2.295 trillion, or 2,295,000,000,000. All right. So what about math? There are some rules when you multiply, okay, and we're going to try this on our calculators then, but I want you to see how to do it by hand so that you have an idea when you plug it in your calculator if the answer is in the right magnitude of 10 or not. So like here, you multiply the first numbers, like 3 times 4. Okay, that's 12. And then you add the exponents for multiplication. So 5 plus negative 8, well, 5 plus negative 8 is negative 3. Now, I don't know if you notice anything wrong there, but this number is not in proper scientific notation. See if you can think why. You see that the 12 is bigger than 10? We need to make the, for it to be proper scientific notation, we need to make the first number 1 or less than 10. So we're going to move our decimal right here and make this 1.2. Now, if I made this smaller by a factor of 10, I need to make this bigger by a factor of 10. And so that's going to be 10 to the negative 2. Again, random line, sorry. When you're dividing numbers that are in scientific notation, and this is my best way to represent division while typing, you want to divide the first number. So 3 divided by 4 is 0.75. And then you want to subtract the exponents. 5 minus negative 8. So if you take 5 minus negative 8, you got to add them. That's 10 to the 13. Again, do you see that this is not in proper scientific notation? Because this is less than 1. So now we need to make this bigger by a factor of 10, 7.5. If we make this bigger by a factor of 10, we need to make this smaller, and it should be 10 to the 12. Now, what I want you to do, after you have both of these examples written in your notes, is I want you to get your calculator and try doing it on your calculator. And I will be available in class or on a Zoom to help you out with calculator help anytime, because everybody's calculator is a little different. Like, for example, let's go back here. What is it? 3 times 10 to the 5th times 4 times 10 to the negative 8. So this is what my calculator looks like. Okay. Now I would, go ahead and plug in like the 3.0. And then when you go to put in times 10 to the 5th, you don't hit the times and 10 and everything. Like, do not hit this button. That is no. You don't hit the times. What you do is right here, there's a button that says double E. When you hit the double E button, that double E means times 10 to whatever number you hit next. So the next number was 5. So you would plug in 3.0 double E 5. That's 3.0 times 10 to the 5th. Then and only then you come back because you're multiplying by another number. Then you come back and hit the multiply and do the 4.0, and then times 10 is the EE button again, and then negative 8. Not minus 8, but negative 8. When you hit equal, you should get 1.2 times 10 to the negative 2. Now, how it's going to look in the screen, okay, is probably something like, well, hopefully it doesn't look like that. Those dang random lines. Sorry about that. Get my pen back. So you should get 1.2, and then over here, it'll just say negative 2. This in your calculator screen means 1.2 times 10 to the negative 2. They just don't show you the times 10. Some of them put a little E in there or whatever. But there's different versions of calculators. Like, this calculator had that double E button. On this calculator right here in the center, you would type in like 3.0, and then you just hit exponent 5, and then multiply by 4.0 exponent, and then where's the negative? It's on here somewhere. There. Negative is up here, -8, and then hit equals. And you should get the same thing. I know this calculator right here, this model, is one that the double E is a second function. So it's one of the blue. So you'd have to do 3.0 second double E, 5 times 4.0 second double E -8, and then hit equals. And you should get this. So pause this presentation, take your calculator, and try to do both of those previous calculations. If you can't get either one of them, then that is absolutely something that you want to, ask me for help, and we can schedule a Zoom session together so that, I might be able to help you. Okay, adding and subtracting. Now, what you do is you put all the numbers in the same power 10. It's kind of like this. Like if I gave you these numbers, to add, one of the first things you would do is line them up, wouldn't you? You'd do like 107, 13, 1.0, and then you'd add them. You're lining up the ones, the tens, the hundreds. I mean, that's what I'd do if I was trying to add those numbers. Okay? You get to line them up. So basically, by putting them all in the same power 10, you're lining them up. So I have 4.5 times 10 to the 5th. To make this one 10 to the 5th, I'm making that bigger by a power of 10. So I need to make this smaller. So it becomes 0.3 times 10 to the 5th. I know that second one is in proper form. That's okay while I'm adding. And I add, and I get 4.8, because you add the 4.5 and the 0.3. And then you just drop the power of 10 down here, bring it along, and here's your final answer. Pause this presentation and try that on your calculator. Again, if you can't get it, please email me, or we can set up a little Zoom meeting together. Subtracting is the same way. Put them in the same power of 10. Again, lining up your decimals. So I have 9.0 times 10 to the negative 3. So I got to make this one bigger again by 1, which means, sorry about the random line. If I make this bigger, I have to make this smaller. So it becomes 0.3. That random line I'm going to get rid of, sorry. 0.3 times 10 to the negative 3rd. And then this is a subtraction. So 9 minus 0.3 is 8.7. And you just bring the power along. And that's your final answer. Try that one on your calculator. And again, here's pictures of the calculators. Remember, you're using this EE or exponent or second function EE. I think it's here. Can't quite see. But, you can always Google too, like your calculator brand and type and ask where the scientific notation button is, or you can Zoom me because I'm happy to try to help. I can figure out most calculators. There are some that I've had a little struggle with. I will be absolutely happy to help you figure it out. So what you want to be able to do from this presentation is take numbers in standard notation and write them in scientific notation, or vice versa. If a number is in scientific notation, put it back into standard. And you want to be able to calculate with your calculator. I think calculating, you're always going to have your calculator, and it cannot be your cell phone. So make sure you have a calculator that has scientific notation on it. The reason I say without is just that you can eyeball a problem and say, gee, if I'm taking something times 10 to the 8th and I'm multiplying it by 10 to the 3rd, I should get something that's in the 10 to the 11th range. Like, 10 to the 11th, sometimes you get 10 to the 12th, something like that. But if you end up with a number that's like 10 to the 5th, you say, wait a second, I hit a wrong button. And that's why I think it's good to just kind of know how to calculate without using scientific notation on your calculator. And then also, if you ever find yourself in a situation where you don't have a calculator with scientific notation, you do know how to add the exponents when you're multiplying, subtract the exponents when you're dividing, and put the numbers in the same exponent when you're adding or subtracting, and just bring that exponent along. So hopefully this has been helpful. And if you have any questions, again, please be sure just to ask.